So we now know Carol is 70.5 inches tall, and we have our bell curve, so we can put her right on here. We know exactly where she stands. They want you to find her percentile. Now that means what percent of the data is below you. So if I was going to shade on this diagram, that would mean she is taller than what percent of people. Now, being that she's on a perfect standard deviation, we can actually calculate this one by hand. So I'll clear this off, and let's look at if she is over 2 standard deviations. We know that being 2 standard deviations from the mean encompasses 95% of the data. We just need to figure out what this tiny little sliver is over there. And so we would say, okay, 95 from 100 is 5%. So again, 100 minus 95 makes 5%. Now those are just the outsides. That's both sides here. So if I only want it on one side, that is going to be 2.5% here if I cut this in half. And so if 2.5% are out here and 95% are there, then our total is 95 plus 2.5, which makes 97.5% that she is taller than. Now in class, so we would say her percentile is 97.5. In class, we just talked about a chart. And this chart here gives us all the answers without even trying. So remember how we know she is 2 standard deviations? If we go back here, she is 1, 2 standard deviations above the mean. If we go look at this chart, at the plus 2, there is the percentile, 97.72%. So if we come back here, that's pretty close here. So we could say from our table, she's 97.72 percentile. Remember, percentile we also refer to as the z-score, and that's why we get it from that table right there. So 97.72% of the people are shorter than Carol. Let's try it again with another data that's not right on a marking. And we will just use the table for now, because you will always have those tables. Carol is 64.25 inches tall. So if we were going to look and estimate, she's going to lie right here. We know she's not on a perfect standard deviation, so we need to convert that height to a standard deviation. So going back to our notes or what we have, we take her height and we subtract it from the mean. That gives us 1.25 or negative 1.25 because she's below. Now that's how many inches she is below the mean. Remember, we divide that into the standard deviation. So that means that she is negative 0.5 standard deviations from the mean. Knowing that, again, we could do this by hand, but let's go back to our table and look for a standard deviation of negative 0.5. That would be right here. So she is taller than 30% of the people. So her percentile would be 30.85 percentile. She's taller than 30.85% of the people. So that's how we use that table. One last example quick. Carol's now 61 inches tall. We would put her right up here at 61. We need to convert her to a standard deviation. That's always your middleman. You've got to get to standard deviation. So we take her 61 minus the average of 65.5. And we get 4.5. And then we're going to a negative 4.5, that is, she's shorter than average. We divide that into the standard deviation of 2.5, and we get negative 1.8. That's how many standard deviations she is off the mean. So let's go find her z-score off the table. Let's go look for negative 1.8. And that would be right here. Pretty small percentile, 0.0359. So convert that to a percent. 3.59 percentile. She is taller than 3.59% of the people. Pretty short.